Alright, so this time we're going to be looking at vectors. We're going to be finding the magnitude of a vector, the length of a vector. So, let me show you, here we got vector v, and I'm going to write it in component form. So I'm going to say that it's equal to 3i, no, let's do a negative. Let's do 3i minus 4j. Alright, so what does that look like? Well, if we were to draw a Cartesian plane, like this, and here's our origin, now we can say that it's 3i, so it's moving 3 across, 1, 2, 3, so that's the 3i component of the vector, and it's moving 4 down, negative 4, 1, 2, 3, 4. That's the 4j component is, or the negative 4j component is a vector going down. That's the 3i. So the actual vector that I'm talking about is from here to here, and that's vector v. And I'm asking, what's the magnitude? What's the length of vector v? Now you could work that out. You already know how to do that because it's a right angle triangle. You know Pythagoras' theorem, so you can figure out the magnitude of it. So it's pretty straightforward. The magnitude, and that's how we show the magnitude of a vector. So that says the magnitude of v, or vector v, is equal to the square root of its components squared. So it's equal to the square root of 3 squared plus negative 4 squared. Okay, and that's going to be the square root of 9 plus 16. It's going to be the square root of 25, which means that the magnitude of this vector is equal to 5. We know the length of this vector is equal to 5 because of Pythagoras' theorem. Now, will this work in 3 dimensions? Absolutely. We can just add in an extra little I, j, k component. We could do the k component if we had a vector in 3 dimensions as well. That's really it. The general rule, if the vector is equal to some number I plus some number j, then the magnitude of that vector, the size of that vector, is equal to the square root of x squared plus y squared. It's Pythagoras' theorem in Math C.